Okay, today this is a video for day 2, evaluating inverse trig functions. Let's first look at last night's homework. Here are last night's homework's answers. And the most important thing to take from this is the location of where sine, cosine, inverse cosine, and inverse tangent, where those exist. So if you look at the range for inverse sine here, the range exists between negative pi over 2 over pi over 2. That is quadrant number 1 and quadrant number 4. If you look at inverse cosine, that's between 0 and pi. 0 and pi is between quadrant 1 and quadrant 2. So that is where inverse cosine is a function. Finally, tan inverse exists between negative pi over 2 and pi over 2. So that is quadrant number 1 and quadrant number 4. All right. So these are the graphs you will be asked to graph: inverse sine, inverse cosine, inverse tangent on your next assessment. And you will be asked to identify the domain and the range. So please make sure you are able to create that. What we are asking you to do right now, and please pause the video as soon as I explain this, is you are going to make a quadrant 1 of the unit circle. Please put in the angles and the ordered pairs. All right, now that you've done that, what you should have created here, it's hard to see, I'm holding this because I don't have my holder today, so I am holding it and writing at the same time. So this is pi over 6, pi over 4, pi over 3. This ordered pair is root 3 over 2, 1/2. Shoot, I forgot to put the extra one in. Root 2 over 2, root 2 over 2, and 1/2 root 3 over 2. In addition to that, you're going to need the ordered pair 1, 0 at 0 pi, and at pi over 2 up here is the ordered pair 0, 1. Okay, so that is very important. All right, flip to the next page. That was page 10, so flip to page number 11. And page number 11 talks to you about different terminology. Cosine inverse is the same as arc cosine. Sine inverse is arc sine. Tan inverse is arc tan. And it just depends on the worksheet and how old it is, who produced it, as to which way it shows up. In homework last night, we mentioned that cosine inverse exists, or arc cosine exists, in quadrants 1 and 2. So you'll notice that that's all that's labeled here. And what we are going to do is we are going to go ahead and fill this in. So this angle is pi over 6. This is 0 pi, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4. Oh, guess what? You do remember these from last time. 5 pi over 6, and pi. And the ordered pairs that go with those, again, we're only looking for the cosine, so it's the root 3 over 2, root 2 over 2, 1/2. This is 1. Up at pi over 2, it's 0. This is going to be negative 1/2, negative root 2 over 2, negative root 3 over 2, and cosine is negative 1. So those are our important values for arc cosine. And again, arc cosine exists in quadrants number 1 and 2. So take a minute and make sure you're copying these down. If you need more time, please go ahead and pause the video. Now we are on page 12. Page 12 is looking at arc sine and arc tangent. Arc sine, as we reviewed today through the homework, flip it to, arc sine is in quadrants number 1 and 4. So again, this is same as what we had before. This is your pi over 6. pi over 4, pi over 3, your pi over 2. Then, remember, it exists between negative pi over 2 and positive pi over 2. So we're not going to write this as 11 pi over 6. We're going to write this as negative pi over 6, negative pi over 4, negative pi over 3. This, again, is at 0 pi here, and negative pi over 2. So it exists for these between negative pi over 2 and pi over 2. And then we are looking for the y value, the second value, the cosine comma sine, the second value here. This is 0, negative 1, so this is going to be negative 1. This is positive 1. And over at 0 pi, second number, which is the sign, is 0. This is going to be 1/2 root 2 over 2, root 3 over 2. Negative 1/2, negative root 2 over 2, negative root 3 over 2. Again, sine inverse is defined between negative pi over 2 down here and positive pi over 2 up here. Tan inverse. So we graphed tan inverse yesterday, and we discovered that tan inverse exists between negative pi over 2 down here and positive pi over 2 up here. So again, that's your pi over 6, pi over 4, pi over 3, 0 pi. And then again, because we're going between positive pi over 2 and negative pi over 2, we're going to look at, positive pi over 6 is pi over 6 up, so this is going to be negative pi over 6. That's pi over 4 up here. This is going to be negative pi over 4. Pi over 3 up here becomes negative pi over 3. Now, for tangent, you're going to have to be careful, and you're going to have to do a little bit of work, potentially. I'm going to fill in all these values. This is a root 3 over 2, 1/2. Root 2 over 2, root 2 over 2, 1/2, root 3 over 2. This is up at 0, 1. This is 1, 0. This is root 3 over 2, negative 1/2. Root 2 over 2, negative root 2 over 2. 1/2, negative root 3 over 2. And this is 0, negative 1. The reason I'm including all of this is I actually have to find the tangent for each one. Tangent is y. Remember, tangent is either sine over cosine or y over x. So this is going to be 1/2 divided by root 3 over 2, which is 1 over root 3. This is going to be 1 at pi over 4. This is root 3, or root 3 over 1. 1 over 0 is undefined. That is why, if you recall at pi over 2, for tan inverse, there was a horizontal asymptote. That's the restriction there. Down here, so this is going to be negative 1 over root 3, negative 1, and negative root 3. And again, tangent is undefined at negative pi over 2. Again, when you looked at the range for tan inverse, it was between negative pi over 2 and pi over 2, but it did not include those. That's why those are undefined there. All right. Page 13 gets into what are we going to be doing with these problems. So I've got a bunch of problems to take you through here. First question. Find the exact value of sine inverse of 1. What basically this is telling you is we seek the angle whose sine is equal to 1. Or when is sine equal to 1? Okay, so if you go back to sine inverse, I'm going to just flash back with this graph we just created, when is sine equal to 1? Well, up here, this is when sine's equal to 1. Sine's equal to 1 at pi over 2. And that is the only time it's equal to 1, because it's negative 1 down here. So the answer to this question is pi over 2. Find the exact value of arc sine of negative 1/2. Remember, arc sine is the same as sine inverse, so it's another way of writing this. So it's asking, essentially, when is sine equal to negative 1/2? So again, you're going back and you're seeing sine is equal to negative 1/2 over at negative pi over 6. So that is the value of the arc sine of negative 1/2. The next two problems are calculator problems. In your calculator, make sure if you press mode here, make sure it's set in radian. And then sine inverse is second sine of 1/3. So do 1 divided by 3. Sine inverse of 1/3. And round to 4 decimal places, 0.3398. So this is just a calculator problem. We are not going to be doing a lot with the calculators. This is just to introduce that these are approximate and not exact values. Notice up top we have exact values of these. So arc sine of negative 1/4. So we have second sine, which is arc sine, of negative 1 divided by 4. And that is going to be negative 0.2527 if you round correctly. Okay, back below, find the exact value of cosine inverse of 0. So it's basically saying when is cosine 0. So you go to see where cosine inverse exists. And cosine inverse exists only in quadrants number 1 and 2. And cosine inverse is 0 right here at pi over 2. So the exact value of cosine inverse of 0 is pi over 2. Arc cosine of, find the exact value of arc cosine of root 2 over 2. So this is saying when is cosine root 2 over 2. So you go to where cosine inverse is, and it's equal to root 2 over 2 only at pi over 4. So if I'm going too fast, go ahead and pause or rewind. Make sure you have your circles in front of you. Your circles that are valid in, again, arc cosine inverse only exists in quadrants 1 and 2. Tangent. Find the exact value of tan inverse of negative root 3. So when is tangent negative root 3? That's what tan inverse is asking. So when is tangent negative root 3? Tangent is negative root 3 one and only one time at negative pi over 3. So that is the answer. So we already have learned a lot of material, most of which is all of what you're going to see on your next formative. The last thing here is classwork that I'd like you to work on page 14. So go ahead and pause the video and try these problems, and then I will go through the answers in a moment. Okay, tan inverse of 0, the answer should be 0 or 0 pi. Cosine inverse of negative root 3 over 2 is 5 pi over 6. Sine inverse of 1 is pi over 2. When is tan negative 1/2, or tan inverse, of negative 1? Tan inverse of negative 1 is negative pi over 4. Sine inverse of 0 is equal to 0, or 0 pi. And cosine inverse of root 2 over 2 is pi over 4. Your assignment tonight is on page 15. So I would like you to complete page 15. There are 9 problems, and have this ready for class tomorrow.